Hi, looking at using similar figures to help us find missing dimensions of um, our figures, and we're also using similar figures to measure for indirect measures, and we'll look at those examples on maps and things. So we have some vocabulary here. Similar figures have the same shape but not necessarily the same size. Things tend to be proportional in similar figures. And we use the little squiggly symbol here to show similar. So they're not equal, but they're similar. So the same shape. So two triangles, two right triangles could be similar to one another. Scale drawings are often similar figures. The actual to the real. A scale drawing is an enlarged or reduced drawing that is similar, again, that word similar comes into play here, similar to the actual object. Scale is a ratio of distance in the drawing to the corresponding actual distance. Scale factor is the ratio of the dimensions of a new image to the dimensions of the old figure. And dilation is a transformation in which the figure and its image are similar. Okay, so there's some vocabulary for you. Moving on to our first example, we are trying to find the side length of x. Okay, and we're told ABC is similar to triangle DEF. So if you look here, AB, first two letters, should be similar to DE. BC should be similar to EF, and the same with AC and DF. So here we have, if you look at the smaller triangle, we have two pieces. We have DE and EF. We have BC on the bigger triangle, and we want to find AB. So we set up our proportion AB over BC, missing side to known side of the big triangle, equals side to corresponding side on the small triangle. Okay, and then we can set this up. We can plug in our information. We're missing x. We have 9 for our BC. DE is 8. CF is 6. So we can use cross multiplication and solve our one-step equation, and we get our missing side to be 12. Go ahead and try the quick check. You can see here I have set it up. It's really important. Setting up your proportion and understanding how to set up that proportion is critical. Whether you do big side over small side equals big side over small side. Okay. You could do big side big triangle over big side small triangle, and then the next side should be small side big triangle, small side triangle. So you just, as long as you set everything up correspondingly, you should be in good shape. All right, let's look at the next drawing here. I'm going to actually draw this one out for you. So we have a flagpole, and it is casting a 102-foot shadow. So here's my flagpole. Okay, anytime you're doing problems, get an image in your head. There's my flag. Okay, there's my little stars and stripes. And its shadow is going to be 102 feet long. So anytime you can, go ahead and make an image. Take the time to think about it. The magic math fairy is not just going to bring down the answer to you. You need to think about your problem and get a grasp on what is happening. So the flagpole casts a shadow of 102 feet. We have a man standing next to the flagpole, and here's my little guy. Okay, and he is 6 feet tall. All right, so he's 6 feet tall, and his shadow is, I'm gonna draw his shadow right here. Here's his shadow, and we know that his shadow, okay, is going to be 17 feet long. Okay, so we want to figure out how high that flagpole is without climbing up the flagpole to see how high it is. So we can set up a proportion. So I'm going to use the man's height, which is 6 feet, over his shadow. Okay, so do you see how I set up my first proportion, my first fraction? Actual height over shadow. So now I'm going to set this up for the flagpole. We don't know the flagpole's actual height, but we know its shadow is 102. So just looking at the, and all of these units here are feet, okay? So just looking at this, do you think you could solve this? Cross multiply. If we cross multiply 6 times 102, we get 612 feet equals 17x. So then if we divide both sides by 17, we should be left with, I'm going to get my calculator out here, we should be left with the height of our flagpole equaling 612 divided by 17, which if we divide 612 by 17, we get 36. So that is now the height of our flagpole, is 36 feet high. Go ahead, pause this, work on the quick check. When you're, oh, I'm sorry, we have another example, then you can work on the quick check. Here we have a map, real world application of proportions. You've got a map. The scale is 1 inch for every 10 miles. So we want to figure out the distance from Valkyria to Gifford. And if we look on our map, here we have a ruler, and we can see that we have 2 and I believe it's 3/8 of an inch, which is 2.375. So we have our distance on the ruler, but we want to know the actual distance. So we can place that as x. And again, we can cross multiply to solve for the distance, which is 23.75. I might have underestimated that a little bit. No, quarter, yep, that looks about right. So go ahead and try the quick check. When you're ready, check your answers. Here we have in example 2, we have a tree that's casting a shadow similar to our flagpole. We get the height of the tree to be 9 3/4 of an feet. Example 3, we now have, we're looking for Grant to Gifford. So you want to watch your ruler there. I think I measured it to be 2.0, so 2 1/16 inches in the map, which is going to correspond to 20.625 miles. Now, if you want to think about if another map showed the distance from Valkyria to Waspow at a scale of 1 to 5, what would the map distance be? So we would change our scale factor here. And here's the distance on our map. And we would get the actual distance to be about 8 3/4 miles. A couple triangles for you to, or figures for you to find missing information. Okay, I've set all of these up. Notice here, triangle, triangle, larger side, larger side. Okay, you can cross multiply all of these to get your answers. But it's really important, like when you're looking at something like this, to recognize that in the big triangle, this is 7, 4, and 3. In the little triangle, we have 3 here. Now, this side is 4, and we're looking for this side. So it's really important that you keep your side lengths in position. Also, don't forget, sometimes they give you pieces and you have to total. Good luck. If you have any questions, please don't hesitate to email me.